Alright, this is chapter 4.5, talking about writing a function rule. As we close up this chapter over the next few days, we are going to be looking at some information that seems slightly repetitive. Since we are looking at an official lesson, though, be sure to approach the topic as if you've never seen it before, so you don't allow any presumptions you have to throw off the lesson itself. Today is going to be a focus on writing a rule for functions, and so I'm sure your essential question is going to be something along the lines of, is this the same as the rules that we've already been writing already? And no, it is not. What we've done is we've been taking ordered pairs and making rules from them by finding the difference and all the other things going on. This lesson here is going to look at actually creating a rule from word problems. It's going to look like a mix of evaluating functions, which is where you just plug in the x to find the y. It's also going to look like a translation thing from chapter 1 where we had to use our words of sum, difference, quotient, product, stuff like that. So, as I said, with what's going on, it should be easy within your reach, but you just want to, again, make sure you take it seriously and not overlook anything. Translating a word problem into a rule requires a recognition of some keywords that we've talked about already, which are each, per, every. Those words indicate that a number should be attached to a variable, and those aren't the only words, but the key thing to know is that any value that will be repeated more than once in a problem more than likely is going to be attached to a variable, and this is best learned through experience, so I think it's best to just kind of get to the examples themselves. Again, these lessons here are very short. There's not a lot of actual deep information. It's just kind of, the topic is about something, so the best thing to do is get in there and just make sure we know what's going on. You're going to be asked to write a function rule to represent a situation. It's going to say they want to know about the total price P for T toys if each toy costs $5.25. First off, the total price is P, and so the best thing to start off with is P equals. Second thing is they want us to use T, which represents toys, but again, the key word here is that each toy costs $5.25, which means that $5.25 is going to happen with every toy you purchase, and again, each means that you're actually going to be $5.25 for every toy, which means you should multiply, and so we want to do 5.25t, and that would be your function rule. Again, the price is $5.25 per toy. If you bought 0 toys, it would be 0. 1 toy would be $5.25. 2 toys would be $10.50, and so on. Alright. Write another function rule to represent the situation. It says the amount y of your cousin's savings if they have $50 less than you do. Again, amount y is going to be my total. So it says your cousin's savings, it says your cousin has $50 less than you do. Keyword here, less than, means it's of course subtracting, and we're going to talk about how much money we have, which would be x, and we want to subtract 50 because remember, less than moves the number to the back of the group. So again, the amount of money in your cousin's savings will be however much you have minus 50, and so that would be it. So again, the rules really aren't that hard to do most of the time, but you just got to make sure you take your time and don't fall for anything crazy. Also make sure you use the proper variables on those because that's part of the problem too. It says another situation, they want the cost C of a pizza is $8.15 plus $35 for each of the or 35 cents for each of the toppings T on the pizza. So again, we have the cost C, which represents a total, and it's $8.15, so we put 8.15 plus, which means plus, and it's 35 cents for each. Again, 35 cents for each topping, which means that we would do 0.35 T because every topping is going to add 35 cents. The $8.15 is what you pay once for the actual pizza, and then you pay 35 cents extra for every topping. So again, it's just a matter of making sure you use the right variable, making sure you understand which part gets the variable, and going from there. Some of the problems go a little deeper, and so we've got the last two examples to kind of look at here. Most of them just get very wordy, and you just got to make sure you take your time and know what you're looking for here. It says you plan to sell bracelets at the mall. The decorations cost $65.70, and the bracelets cost $3.75 each. Write an equation expressing the cost y of the project in terms of the number of bracelets sold x. What is the cost of decorating 27 bracelets? There are actually two questions on this. First thing they want is an equation. Second thing they want is the cost of decorating 27 bracelets. So we got to get the equation first. And again, it wants the cost y, so we're going to start with y equals. First thing is the bracelets cost $65.70. I'm sorry, the decorations costs $65.70. So $65.70 is a one-time purchase there. So again, the cost for the decorations is $65.70, and which means we're going to have more. The bracelets cost $375 each. Again, the key word there is each, which means we're going to put 3.75 x here. And so that would be everything you're paying. Again, the equation is going to be y equals $65.70 for the decorations plus $375 for every bracelet. Again, $375 for every bracelet we sell plus the $65.70 that we originally purchased for the decorations. But the second part is going to be important. You want the cost of decorating 27 bracelets. And so what that means is, if you remember that bracelets is X, and so we simply got to take that 27 and plug it in. So we are going to do y equals $65.70 plus 3.75 times 27. Good news is we've been working on using our calculator, so this shouldn't be out of our range. We're just going to go ahead and take this and type it in the way we see it. $65.70 plus 3.75 times 27 means it's going to cost $166.95. So your equation is here. That is the rule based off of the word problem, and this is the total for 27 bracelets. Okay. So again, identify the word each. Make sure you read it carefully. Again, any problem like that where they're buying decorations, that's a one-time thing for the decorations, and they're going to use those decorations to decorate everything. So they're not going to spend $65.70 more than once, but they're going to spend $375 every time something else is purchased, which is why that $375 should get an X. Last example. This is the tricky one. That's why it has an asterisk by it. You might want to make sure you pay attention to this and highlight it, because this question is slightly tricky. It talks about a taxi driver charging $5.25 for the first 3 miles and 95 cents for each additional mile. Write a rule for describing the total rate R as a function of the total miles M. So again, we want the total rate R, which of course means that we're going to do R equals. The hard part of this problem is that it's not going to be simplified at first, so we got to make sure we simplify it. So what we have to do is kind of take the information and write what we know. First thing is, you're going to get charged $5.25 for the first 3 miles. So it's going to be $5.25, and that is a solid amount no matter what for the first 3 miles. And we're going to add on 95 cents for each additional mile. But this is where it's tricky, and this is where the asterisk is here. You've got to make sure you study this when you get your time and look at it and figure out what's going on. It's 95 cents for each additional mile, but you got to remember that the first 3 miles are free. And so what you want to do is take 95 cents, because if you think about it, 1 mile, if M is equal to 1 mile, we're not going to have any extra charge. If M is equal to 2, we don't have an extra charge. If M is equal to 3, it's still no extra charge. But when M is equal to 4 miles, you only get charged once. So that's where your 3 kind of comes in here. And so what you're going to do is you're going to subtract 4 minus 3, which means that we get charged once. When M is equal to 5, we're going to subtract 3 and we're going to get charged twice, and so on. So that 3 miles kind of adjusts what that number is. So it's not just going to be an M, it's going to be M minus whatever that part that's free is, or not free, but the part that's in the original price there. And so you end up with $5.25 for the first 3 miles, plus 95 cents gets charged every mile after 3. So again, that's why you've got to subtract 3 from that, because 3 miles would be none. 2 miles, 1 mile really wouldn't work in this situation because it would just be $5.25. But in terms of your general equation, you've got to make sure you factor in that the first 3 miles don't get charged 95 cents, but the 4th mile does, the 5th mile does, and so on. When I say it has to be simplified, you've got to make sure you actually do it the right way, because if you type this in, that's not a simplified version. It's not going to work on MathXL. It would work on your or actually I don't think it would on your test, because they want everything simplified. I think I wrote that wrong. It'll be 0.95 M minus, because we're going to distribute here, 0.95 times 3, which is 285. So minus 2.85. So now we've got to take 525 and 285 and combine them, and that is a negative 285 to get 2.4. In other words, it's about $2.40 first when you get in there, and then they're charging you 95 cents a mile after that. So other than that, that is your simplified equation there. But notice that we have a second question which says, what is the cost of a 17-mile taxi ride? Again, 17 mile means put 17 in for M, and so we do R equals 2.4 plus 0.95 times 17, which again is something we should be able to just type in. And we get the answer of 1855. Just to make sure this works, I want to go ahead and try this with the number 3 to make sure we get the answer of 525. 2.4 plus 0.95 times 3, and you notice that you do get your original 525 for a 3-mile drive, so that means that that was a proper transition. So again, your 17-mile taxi ride is this much. That is your general rule for anything with M greater than or equal to 3, because again, 2 or 1 mile is going to be just 525. It wouldn't be less. But other than that, as I said, this is where you got to make sure you practice your parts. This is where you got to make sure you come back to your homework, and if you're greedy about trying to do well on your assessments, that you got to make sure you ask whatever questions necessary and keep fighting until it kind of sticks. The final thought with the material of each section getting more and more specialized, which that's what it's doing, just be sure you're not forgetting how to do the processes from the previous sections. Use your homework and notes to review so you stay sharp. The best thing you can do is to hit similar question or similar problem or whatever it might be. I don't know what it says on your Math Excel, but it has something on there where even if you have a question correct, you're allowed to hit a button that says similar problem, and it changes the numbers around. The best thing you can do after you get 100% on your homework, which is why we're working to do this, is that you want to go back through all the homework questions and kind of click through them until you see a question that you really don't remember. Hit similar problem and work it out. The good news for you is that the problem's always going to be, your assignment's always going to be 100% once it's 100%, but you want to get more practice on the things that you don't remember. You've got to start making sure you learn to do that. That is honestly how you get further and further into your math. If your work is on paper, you might be in a different class, but if your work is on paper, then that's where you go back through that paper, you look at the questions that you've done, and you circle the ones that you still don't remember, and you work those out on a separate sheet of paper. But in math, the only thing you want to do whenever you're trying to get ready for a test is you want to work out the problems that you don't know, not just work out the ones that you do know, because if you already know them, there's really no point in spending more and more time on it. But the whole point, the whole purpose of the math problems and studying is making sure you spend time with the questions that you have issues with. So sorry to talk so long and talk your ear off, but that's a very important thing, and you have a very important chapter test coming up next week, because it is the first test of the chapter, and first test of the quarter, and you don't want to put yourself into a bad range and be off level. So other than that, Math Excel is waiting, so good luck.